Pictures of the world, right? No, hold on. That would have been the 26th. Are you on the right thing? Secret of my own. That. Okay. So submission failed. Okay, so we need to resubmit. So go back to your thing.
Hopefully it didn't get.
No, it's okay. Just resubmit it. I apologize, y'all. It's I'm trying to do you guys and do my third grader all at the same time. So I've got more people that have Gingen. Hold on here. Let me figure. Okay, Veronica, you. Okay, so we should all be logging into Canvas. My screen should be pinned. It should be. Should be pinned on the opener right now. Yeah, it looks like it's pinned. Hopefully, oh gosh, I love my child to death, but hopefully that's the last little interruption that we have because she's confused, just like we all are. So this opener, this is the last topic in the Unit 3 test, which will be that will be actually next week that we will do the Unit 3 test, which is over this confusing electron configuration. And now we are ending with light. Light is the very, very last bit of it. But the opener asks, first of all, what is light and what produces it? And hopefully y'all know what the main source of light is on our planet. Don't think about technology, think natural light. What is it and what produces it? And then the next question goes on to say, are there different types of light? I'm telling you right now, yes, there are. There's a bunch of them. And can you name at least 2 of the different types of light? Because you're only going to think of one type, the type that we see that has a name. There's other types. So first of all, think about what's actually producing the natural light. Okay, not the lights in the ceiling, not those, not flashlights, not cell phone lights, natural light. What's actually producing it? And once you think about what's producing the light, can you think, besides the part we can see, is it producing a different type that's still considered light? It's still electromagnetic energy. What are the other types? Now, there is the activity today is completely in Canvas. It's a Canvas quiz. It's 10 questions long. Let's see, you guys are 4th period. So you don't have CVAs tomorrow. You have them Thursday. Okay, they're done the same way through that online system. You have to have your Chromebook to be able to take them. You can use your colored periodic table on that test, and I am going to come up and leave explicit instructions for the substitute. I can't remember who it is off the top of my head. I'll have to go back in my email. If you are a student that normally frequents the Learning Lab, like that is actually a modification for you, and I had written you down last 6 weeks to be able to utilize it. I heard ding. Then I am going to set that aside if you choose to do it. I hear there's something. Well, Sebastian, let me go back and take a look without. Let me look. There's a few grades I've not put in. The most recent ones that, like the ones on the quantum theory. I don't think I put in no, I did put in quiz element 2. I did. And if you just turned in the thing on quant, then I'm working on that. So for you, I can get, sorry if you can hear my cat purring. He's literally on my keyboard. And I've already dropped 3 daily grades to answer the one that is asking about a grade. It is the 1, 2, 3, 4, 5, 6, 7 missing daily grades that are killing you. And I tried to make that evidently clear. Show cat? I don't know what you mean, Sebastian. I don't know. Is this purring dog?
Okay. Okay, so you said your cat was like purring on your keyboard. I want to see your cat.
Okay. Okay. Hold on. I guess I can activate my thing. Just realized I don't even have my. You can't see me. I don't know if I can make my thing move this way. Hold on here. Let me fix that here. Let's see. Let's see if I can. Here, hold still. That's him. He's got this really gross thing on his side. Okay, but that's him. Okay, so I just realized that I think. Oh crap! No, hold on. The thing's stuck underneath my computer. Let me fix everything. Alrighty, so hopefully I've stalled enough to give y'all enough time to do the opener. I'm going to double check attendance one more time, even though I know that the substitute that's in the room is supposed to be doing in person. You guys keep coming on and going away, so okay, I see Aiden. Okay, I see Bailey. Bailey, I think you're at home again for 14 days, aren't you? Tiffany and Veronica. Okay, so I have a few of you, as of this morning, at least when I double checked it, that you're missing a test from the 22nd. Hold on, let me look and see what date that was. That was the 21st. Okay, so I am missing that test still from Veronica, Lucas, Matthew, Haley, Valerie, Eva, and Braden. And it should still give you an attempt. There is a time limit on the test. There's a counter at the top. So make sure if you're going to go back and do it, that you have enough time to be able to take the test. You do need a periodic table to be able to take the test. Open this up. Show all screens. All right, so we are getting ready to start light. Sebastian, I don't know what you're watching, but you're going to get off of that. And I'm going to start recording y'all screens. And I'm going to start turning you guys into the principals. So that needs to go away. That needs to go away. Let's see, who else? There's another one. Jared, get off the YouTube. Who else is doing it? Y'all seem to not think that I can see this. Okay, so y'all need to open up the notes. And if I open up mine, which is pinned to my screen, so y'all don't need to be actually looking at me. In fact, in case my cat is going to end up putting his butt in the screen, so I'm going to take that off. It's just, he's a typical cat. I don't want to subject you to his cat booty. All right, so characteristics of light. And y'all have these notes. And I'm pretty sure I went back and I underlined the things that need to be filled into the holes. But there are certain characteristics that we have of light. Now, you guys think light is what you can see, which is partially true. Smack dab in the middle. Visible light, that's what we see, comes from the sun. Okay, but there's tons of other things that the sun gives off, which is what is called electromagnetic radiation. Now, visible light is just a little bit of that. Okay, it can travel through space. It does so as a wave. If light couldn't travel through the vacuum of empty space, then we wouldn't have life the way that we know it here. But now the word oscillating, and I put that on my slide because you probably have never heard that word before. It just means that it's vibrating back and forth. It's repetitious. And so if you think of like a slinky, if you put it in your hands and you start shaking the opposite things up and down, you're going to get that wave pattern, sort of like a snake that's going up and down and up and down. That's what oscillating means. But it's oscillating with both electric properties, and it's also oscillating with magnetic fields. That's electromagnetic. They're very inventive with the name of this. It is part electric and it is part magnet. And they're both moving specifically perpendicular to each other, but y'all aren't going to be tested on that part. But they are moving back and forth. Pretty sure that's the last thing that's on this slide. So let me go back to this. Okay, so you guys also have this on your canvas. You do need to put that 1 nanometer is 10 to the -9th meters, or you could say that 1 meter had 10 to the 9th nanometers in it. They mean the same thing. But this is the entire EM spectrum. And if I say EM, it's just short for electromagnetic. Like I said, this part right here is what you guys need to be filling in down on the side. And the part that you think of as light, this little section right here that we see, and we call visible light because we can see it and we make up all these rules. And so since we can see it, we call it the visible spectrum. And there are 3 primary colors of light. Now, please don't confuse art, paint, with light, because in art, it's not red, green, and blue. It's red, yellow, and blue with paint. This isn't paint, this is light. And let's see, make sure if you guys are being bad, I gave the substitute my cell phone number. You just texted me. If you've ever seen an old school television, the ones that are like really wide, we call those cathode ray tubes, and you get really, really, really close to the screen, you can see the little red, green, and blue dots because those 3 colors of light make all the other colors that we think of. But like I said, that's just this itty bitty teeny tiny little bit. And we have the really big waves, radio waves, which is how radios work. Okay? And then we've got the FM, and this is all part of radio waves. Then we've got microwaves, which is how a microwave works. Once again, very inventive. Infrared, there are animals that see in infrared. If you've seen the movie The Predator, that's how he was trying to find Arnold Schwarzenegger. We've got goggles we can wear to see heat. And then on the other side, ultraviolet, there are animals that see in UV. Bees, pollinators, not dragonflies, butterflies, they can see in UV. This is what causes sunburn. Then we have X-rays, and then the really, really nasty ones, we've got gamma rays way up here on the side. And so all light waves, and EM is short for electromagnetic waves. Make sure that I did not miss something. No, okay, they have 4 primary characteristics. The first thing, and characteristic is just a way that you can tell one light wave apart from another. One is wavelength. Okay, and then the other major one is frequency. Now there's 4, but these are the first 2 that we actually talk about. And there's a formula that I am going to show you. Well, my coworkers are texting me. Okay. So a wavelength has this weird looking little symbol. It sort of looks like an upside down Y that's tail is going the wrong direction. It's a lowercase L in Greek. But a wavelength is the distance between 2 crests or 2 troughs. And okay, it's just crests that's open on y'all's. And that little symbol that you guys have on your notes page, it's not English. Okay, that's Greek. That's why it doesn't, in fact, we use a lot of Greek letters. It's like an upside down Y, okay, but the tail goes the wrong way. Like I said, it's a lowercase L in Greek. And then frequency is how many times the wave happens in 1 second. When that fancy word that we were using on the other slide was called oscillating. How many times does it repeat? Complete repetitions in a second. These 2 are the primary things that we're going to use to tell apart light waves. I just haven't shown you the formula, and it's a little 3 variable formula, just like density was. It's not anything crazy. It's just you've got some symbols that you've never seen before, and you're going to have some units that you've probably never heard before, or at least you don't realize that you've heard them before. Next one, amplitude. Was I supposed to underline something from its what position? I did not underline it. Its rest position or its original position. And then it looks like I forgot to do speed of light needs to be underlined. So on these, this is the one that you're filling in. Or you could say original position. And then you're also going to be putting in the speed of light. Oh, it made the little 8. Oh, well. Okay, so amplitude is the height from before the wave started. So if you think of a flat body of water, like there's no wind, there's no ripples or anything, smooth, and you throw a rock in there, you're going to see the ripples. You're going to see the ups and downs. The tops are the crests and the bottoms are the troughs. But half the distance from the very, very top to the very, very bottom was before they actually threw the rock in. So that's what.
How do you do exponents?
Exponents Exponent. Okay, so what you do when highlight the 8 and hit control, I think it's control period. If it's not control period, it's control comma. One is a subscript and the other is an exponent. Did it work?
Yes.
Okay. Yeah, it's if you just highlight over it with Google Docs, and I'm pretty sure control period is the superscript, which is what you want there, and control comma is going to be a subscript, which we're about to use a whole bunch of them when we start doing compounds next 6 weeks. Okay. So I gave you guys this picture too. At least I should have. Let me double check. Yes, I did. All right. So that funny looking little
Can we go back to that last slide real quick? I didn't get to finish.
Sure.
Okay.
Sure.
I got it. Thank you.
Got it? Okay.
Do you hear how loud these kids are?
Yeah, I do hear how loud they are. Okay, so let me go back to the right slide. I got like 50 tabs open. All right, so I gave you guys this image on your notes page, and you got that weird looking little symbol that's repeated twice, and you have the capital A. Okay, so these are both representing a wavelength. A wavelength either goes from one crest to the next crest, okay, or it could go from one trough to the next trough. So the tops, those are called crests. It's the high point of a wave. And then the bottoms, these are called troughs, not through trough, like the thing that you feed livestock in, the bin that you put food and water in for like cows and pigs and stuff. It's called a trough. And those are the bottom parts of the waves. So from one crest to another would be a wavelength. Once again, that's how we do wavelength. Or from one trough to another would be a wavelength. So this wave has a total of 1, 2, 3 full wavelengths if I'm starting from here. So if I start here, then I end at the same spot. So this is a wavelength. This is a wavelength. This is a wavelength. It's wherever you start once you get back to the same spot. So this is literally 1, 2, 3 wavelengths. The capital A, this is amplitude. It's not the total height. That's called displacement. It's from before the wave happened. So this would be the resting position to either the very top, or you could say the resting position to the very bottom. That's amplitude. Let me double check online, see how many of you guys are. I don't see anybody new. Check here. And I do know that there is a way to do a side-by-side with your screen. I know if you had a touch screen, you sort of pinch the screen so that you can get to. I'm not sure how you do it with your trackpad. Let me go back to the right slide. All right, you guys also have this, but what you do not have are these words up here at the top. So the largest waves at 10 to the third, which can be huge, those are radio waves. They have the longest wavelength. And the bigger the wavelength, okay, the better off it's going to be as far as damaging you. That smaller that wavelength, the larger the frequency, and the frequency is actually what's damaging you. I haven't shown you that formula quite yet. I mean, it's on your notes if you look down with the equations. But your least dangerous waves are the ones all the way on the left. Those are your radio waves. And like I said, that's how radios work. They're around us right now, all around us. They're in the room with you. They're in the room with me. They don't hurt us. That's how your satellite television talks. If you have DirecTV or like Dish, or if you use like internet, like satellite internet, that's how they talk to those satellites in space. They use radio waves. Microwaves, not sure what's going on. I'm getting dings left and right. Microwaves are literally how a microwave works. Now, I'm not saying stick your head in the microwave and hit start, okay? But regular old microwave don't hurt us either. They have to be focused. And so if you stick the hot dog in the microwave and you cook it for 5 minutes, it's going to explode because those are focused microwaves. And no, you cannot charge your cell phone with a microwave. Infrared are heat signatures. We have a way to see infrared, not with the naked eye, okay, but we have instruments that we can use to see this, where the really, really warms are your brighter colors and your really cools are going to be your greens and your blues. That's infrared. Snakes, some of them can see this way. We see with visible light. Some animals can see with ultraviolet, but this is what causes sunburn. X-rays, obviously, we use them in dentist's office, in dentist, doctor, broken bones, cavities. Okay, but if you're just exposed to X-rays for a long period of time, it will kill you. It is not good. I mean, you get X-rays for a reason. It's focused. They know what they're doing. But if you just stand in an X-ray machine, you're going to die from radiation poisoning. And then the really nasty ones are gamma rays. And this just sort of tells you how small that wavelength is. So radio waves can literally be as tall as buildings. The visible light, those single-celled organisms, hopefully you looked at in biology, and then gamma rays literally the size of an atomic nucleus. We have some equations. They're not hard. And you guys have this. This is that weird looking symbol, sort of like the upside down Y with the tail the wrong way. This is the way that Google Slides does this letter. It really should be more of like a curvy line, but I couldn't pick and choose really with Google Slides. But C is the speed of light. It's 3 × 10⁸ meters per second. 300 million meters per second is how fast that light travels in space. And it's a speed, so it's meters per second. F is frequency. Oh, that's supposed to be, that is not right. Hold on, let me fix that. Control C, Control V, there we go. Okay, so I thought I did frequency next, but I didn't. I did wavelength. Now that I fixed my image. That weird looking little thing, if you want to know how I did it, I went into format, and then I went into, it was text, I believe it was, my screen has frozen. Oh, lovely, my screen's frozen. Okay, so I went into text. It's not gonna let me do it. It's going crazy. It's a lowercase L. Text. Okay, somewhere in here, there's a way for me to change my format. It's not going to let me. I can't remember how I did it. Insert. It's not shape. Somewhere there's a symbol thing. I'm not seeing it. Oh, I just did this yesterday. If you want to, for right now, you can put a lowercase L there. I need to figure out. Sarah, this is a bad time to come in here. Yeah. Okay, well, can you get, here we go, special characters, that's where it's at. Okay, so if symbol, lowercase L. Let's see here. It's under symbols is where I got that from. And I can't remember where it is that's in it. There he is. It's under lambda. Okay, so what I just did, since you guys can see this screen, is I went under special characters. Okay, and then when I clicked on that, I typed in lambda because that's the name of the letter. And really, I should have probably used this guy because that's actually what it looks like. So I'm going to change the way that that looks on here because it is supposed to be a curvy little line. And I could go back and show you guys how to do that in a bit. And then the other thing, Sarah Jane, I'm in the middle of the class and I am going to not be very nice to you.
I have to get that from you.
What do you mean I have to join the meeting? I'm doing it right now. You're Sarah. If you receive an invitation link, tap on it. It may not have one open right now. I think she's at lunch right now.
That means it's lunch.
Yeah, it's lunch. Okay, so you can go have lunch. Hey, take your iPad. I'm sorry.
Go plug it in.
Go plug it in. That's right. Okay, and then so wavelength is a length. It's measured in meters. And then frequency has two possible units. These mean the same thing. Either it's 1/2, which is second to the -1, okay, or it's called a hertz. Okay, when I teach physics, I almost always use hertz. I don't use s to the -1 or 1/2, but they do both mean the same thing if you see that. All right, so the equations. We have another one. It also has 3 bits. The energy of your light particle, which is what a photon is, and that's in joules, is equal to Planck's constant, which is 6.63 times 10 to the -42nd joule seconds. And I need to go back and look and see. And I did. I gave that to you. Oh, that's supposed to be 34th. I have a typo. Fix it. 34th.
So I just asked
Oh, Sarah Jane.
Join me in making the spikes. But she said no because that she's at lunch. Or
Okay, she's at lunch, baby. I'm sorry, y'all. Okay, I fixed it. But that is a constant, and I don't make my students memorize constants, just like I don't make my students memorize conversion factors. I provide them to you. If I can't put it on the test, I end up putting it on the board. I haven't even seen your 6 weeks assessment, which is Thursday. I don't know how many questions it is. I can tell you that you can use your colored periodic table on it. Once I figure out exactly what's on it, I will go up and I'll put instructions on the board. Now, frequency is still in 1/2, which is what this means, or hertz. Texts from people. Okay. Let me go back to this. All right, so the next one, oh, you guys had all of this. So it's just a matter of learning how to rearrange these equations, learning what their relationship is. Now, the third one does have stuff that you guys need to put on it. We go back to Albert Einstein and the theory of relativity, where E equals mc squared. In fact, I'm going to change this to be the right one also. And he said that these particles, these rays, as they go through space, are called photons. Now, specifically, a photon is a particle of visible light, the part that we think of when we say light. And then he went ahead and put these together. He smashed them together to make that the photon particle is equal to Planck's constant times the speed of light divided by the wavelength of said wave, which is what this is literally saying. So your light energy is equal to Planck's constant, which was that big number that I just fixed the superscript on, times the speed of light, which is 3e8 meters per second, divided by the wavelength. That's all he did, was he just smushed them together. So, and I forgot to animate this properly. Fix that. Animate. Get rid of. Animate properly. Okay, so even though you guys just saw the right answers, if the frequency of a wave is doubled, and now we're not changing the speed of light. The speed of light is constant. It's moving at 300 million meters per second through space. So, and I need to change this to the symbol, but I'll do it in a second. So if I double the frequency in order to keep the speed of light the same, then I must do the opposite to the wavelength. So if this is doubled, your wavelength is going to literally be cut in half. They do inverses of each other. Once again, the speed of light in space is not changing. If you double the wavelength, then you would cut the frequency in half. If you double the frequency, then you would have to cut the wavelength in half. They literally are doing inverses of each other, and I'm going to fix those symbols so that they look more like how they are supposed to. It's just a concept. You guys aren't actually crunching any numbers right now. It's if the speed of light is the same, which it is, it's not changing unless you change the medium, and that's like physics stuff. We're not going into that. The speed of light stays the same, then they do opposites of each other. If the frequency is 3 times more, then the wavelength becomes 1/3. If the wavelength is 4 times more, then the frequency is 1/4. They literally do, reciprocal would be the other word that you guys have heard. Let me look and see what you guys have on. Okay, so the next one, I'm not sure how many of these I just answered because I'm just looking at your questions. So, oh, this is not animated either. And I just went through and I double checked this and I fixed it and I didn't fix it the right way. Okay, so next one should be if the frequency of the wave is doubled, what happens to its wavelength? It does the opposite. It's a half of what it originally would have been. If your wavelength is tripled, we're talking about a different equation here. So, and I need to fix that so that that symbol looks proper. But if we triple this, what is going to happen to the energy? Well, if this becomes 3 times bigger because it's in the denominator, it's going to do that same thing in reciprocal form because it's divided by 3, so it would become 1/3. That is assuming that the speed of light does not change. Planck's constant is the constant. It doesn't change. So this essentially becomes 1. If you put a 4 down here, the energy is 1/4. If you put a 5 down here, the energy is 1/5. Let's see here. Make sure I'm on the right question. If the wavelength is tripled, what happens to the energy? Okay, I see where I'm at. And probably my next slide did not animate properly either. I'll have to go back and fix it. Sometimes it does it right the first time, and other times I have to go back and remove it and alter it. I'm going to change that guy to the right symbol. All right, now the next part should be the next question. And of course, it did the exact same thing that the other ones did. Delete it and let me fix it. So that next question, if the wavelength is halved, if it's cut in half, if it's halved, what happens to the frequency? So once again, this can't change. If this is 1/2, then this is its inverse and it will be doubled. They literally are doing opposites of each other in this particular one. What makes different forms of electromagnetic radiation different? It is characterized by their wavelength and their frequency. Their speed will be the same in a vacuum. That's going 300 million meters per second. That's not changing. So it's going to be the other bits in this equation would be the frequency, which is normally in hertz, but it could be s to the -1 or 1/2, or it would be in wavelength, which will be in meters. Okay, now that should be the end of this particular one. Oh, I didn't mean to give you guys 2 different things, notes. Now, like I said, you guys do have a 6 weeks test coming up. I have not seen it. I do know what your question.
What's the next question?
The next question, did I not have it on that one?
No, it's on the.
Okay, it says what makes different forms of electromagnetic radiation light different? That question?
Yes, that question.
Okay, it's this last line. What makes them different is their individual wavelength and frequency. It's not their speed. If they're going through light waves, okay, so
That's what I was confused on. That's what I was trying to ask again.
they're only told apart by their wavelength and their frequency, and they do opposites of each other. But when they're traveling through space, gamma radiation, ultraviolet, visible light, they're all traveling the same speed. They enter our atmosphere, they encounter particles, they slow down, and they bend, but they're all traveling the same speed. They enter water. I don't know if any of you guys fish. You know that fish is not where it looks to be because the light slows down when it goes from a gas into a liquid. And then the same thing happens when it goes into a solid. Every time you have a sturdier medium, solid, liquid, gas, plasma, the light bends. And that's why if you go fishing, that fish is not where it looks to be. The light is bent. It's not where it appears to be. Or if you put a straw in a glass of water, why it looks like sometimes that straw is broken and then it continues on. The speed of light's change. That straw is not really broken. So anyways, I sort of went off on a tangent there. They are told apart by their wavelength and their frequency. Now we have about 5 minutes left in class. Now, I just went over and told you which of you were missing your test. Okay, so if I look at, let me find the right page. If you guys are online, that would be Veronica, that would be Lucas, that would be Matthew, that would be Haley, Valerie, Eva, and Braden. It is the test that was from the 21st. You should still be able to take it because those tests, I don't build those tests, a different chemistry team member does. And I don't think there's a time, like a cutoff on that. You just haven't taken it. And then if I go into the grade book itself, I can't remember what I've put extensions on and what I've not, but most of this electron configuration stuff, I am being very, very graceful and giving you a lot of time to be able to do it. Missing, and I don't know if you can still go back and do the opener from the 22nd, but a whole bunch of you did not do that. The quantum mechanics sheet, the intro, a lot of you did not do that. I did see Robert just turned one in, and I see it looks like Matthew turned one in. There was the opener from Friday, which was the element quiz. I can't remember if that one is still open or not. There was the assignment from Friday, which still should be open. I've seen a few of you turn them in, but I've not looked at them yet. There was the opener from yesterday. Excuse me, there was the assignment from yesterday, which a lot of you still need to do. Most of you did the opener today, and it looks like some of you have already done the assignment from today. So tomorrow, what I plan on doing, because I only have you guys for a short period of time, is you got to get your notebooks together. And if you've been taking notes on paper, you have to digitally move them over. And this was your question, Jimmy, if you are still online. I cannot check paper notebooks. I mean, I'm not sick and my kid's not sick, but I'm technically not supposed to be up there. I come up there in the morning before anybody else is up there. So if you've been doing paper, which I know is yours, Jimmy, if you have a scanner at home, awesome. Start scanning them and send them to yourself. Okay, if you don't have a scanner, it's not the end of the world. Take pictures of them with your phone, send them to yourself. And then if I change the way that I'm presenting to my entire screen, okay, in Canvas, it's thinking, my computer is thinking. Come on, you can do it. I can't tell if it's showing the right screen. Okay, it looks like it is. So in Canvas, second 6 weeks notebook submission. Okay, I know this is Earth Space Science. I recorded it from them. Just replace Earth Space Science with chemistry in first 6 weeks with second 6 weeks. And this walks you through how to do this. Now that's what I plan on doing tomorrow with y'all. It's a short class with you tomorrow. You've got a list to the copy of what I'm looking for this 6 weeks, okay, which are these, including today's. Okay, and then the thing that was underneath that, this is YouTube link. Now, you do need to make sure once you get everything into a folder, which just explains how to do, and we'll go over it tomorrow, that when you go to get that link, not the share button with the person, but when you go to get that link, that you've got to switch it to Azel, or y'all, I won't be able to see it. Like, I can see you submitted it, but I can't look at your drive. So that's what we're going to do tomorrow. There are a few things that are unlocked, not a lot, okay, but there are a few things within the last week that are unlocked that you can go back and make sure that you've submitted, not put those into, some of them I've not put into Parent Portal yet. Go back to this. I don't think. I don't see any other questions.